Hi, sixth graders. We are starting a new unit, which is Unit 7. So a new spot in your notebook, Unit 7, Intro to Algebra and Equations Unit. So that can be your title of this whole next unit. And then this topic of this lesson is addition and subtraction equations. So label this for what you're going to have for this Unit 7 unit. And then just for this topic is addition and subtraction equations. So at the end of this video, we want to be able to solve addition and subtraction equations. So let's think about what we know about the equation x plus 5 equals 8. So basically this is what this is telling us is that a number plus 5 equals 8. A number, meaning the variable x, which stands for an unknown number that we have to figure out, that's our variable, plus 5 equals 8, which we know in our heads right away probably is that that number is 3, because we know that 3 plus 5 equals 8, but without even realizing it, we're actually in our head kind of doing 8 minus 5, kind of going backwards, and we get 3. So that makes us realize that x is 3. That's an easy one. We're going to learn how to solve all of the equations by using different steps and how to get there. But that's really what is happening when we're solving equations and when we're trying to figure out a variable is what can we put in for that value to make the sentence or the equation, sometimes this is called a sentence, or an equation to make it true. And we know that x plus 5 is the same as 8 equals, can also be thought of or written as the same as. All right, so whatever you do to one side of an equation, you must do to the other side to have the sides remain equal. So this is something that I would like you to write down in your notebook. Whatever you do to one side, you must do to the other side to have the sides remain equal. Kind of like fractions, like whatever you do to the top, you have to do to the bottom. For equations, you have to do the same to the left and the right. Inverse operations, that's what we are going to use to help us solve the unknown variable. So inverse operations, you can just write the word inverse operations. And then instead of writing all of this underneath, we know that the inverse operation of addition is subtraction and the inverse operation of subtraction is addition. So we're just going to write addition and subtraction. They are inverses of each other. And then multiplication and division are also inverses of each other. Steps for solving one-step equations. I want you to write all 5 of these steps down. This is what you're going to use for our next video for multiplying and the next one for rational numbers. So you'll only need to write this down once, but I would like you to have all the steps down. So you're first going to write the equation. Then you're going to draw your slide or your train tracks. Then you're going to use the inverse operation, which we just kind of talked about, solve for the variable, and then you're going to check. So those steps you're going to use for every single equation that we're going to solve coming up. All right, so let's do some together. I want you to write down all of these as I do them. So there's 6 addition, 6 subtraction, and I want them all in your notebook so you can practice doing the steps and you can have lots of examples to look at for when you go back to. All right, so we have x plus 6 equals 4. So write that down. That was our first step, writing down the equation. Then we're going to draw a slide or a train tracks. I'm just going to call it a slide. And the purpose of that is to separate the left and the right side. And the slide just is 2 straight parallel lines that can go down and stay straight, so it really truly separates the left from the right. Okay, x plus 6 equals 4. So we're asking ourselves, what number plus 6 equals 4? You probably can do all of these in your head maybe, but we're going to do these easier ones so we can get used to the steps, and that when we have harder ones, then we know the steps by really well. So I look at my side with the variable, which is the left side, and I can see that's x plus 6. So I'm going to do the inverse operation. The inverse operation of addition is minus, or subtraction. And then I just pull down the 6. The point is so that this right here is canceled out. I know that 6 minus 6 is 0, and anything plus 0 is just itself. So that's the point. We want to get rid of it. But if I do this on the left side, then I have to do it on the right side. And then I'm going to draw a line all the way through so I know that that is my first step. Okay? So I know 6 minus 6 is 0. So I have x plus 0. And then I have 4 minus 6. And I'm just going to rewrite this here just so I can see that 4 minus 6 is the same as 4 plus negative 6. I know x plus 0 is just x. 4 plus negative 6 is negative 2. Before I just say that that's my answer and move on, I have to put it back into my equation and check it. So I'm going to rewrite the equation, but instead of putting an x, I'm going to put a negative 2 in there. So negative 2 plus 6 equals 4. And I ask myself, does negative 2 plus 6 equal 4? Like, actually stop and take a second to think, negative 2 plus 6, yep, that equals 4. So yes, that works. So that's my answer. And then sometimes I see a lot of people just, yep, that works, and not even actually thinking about it, because this is the best. This is like the easiest type of problems to see right away if you're correct or not. If it doesn't work, like say these don't equal each other, then that just means we made a mistake up here somewhere, either on this side or on this side, and we just have to go back and recalculate until we get these two sides have to match up. This right here has to be 0. So right here, these can kind of cancel out into 0 and leave x alone. So there's a few different ways that you could possibly maybe screw up. All right, y plus 9 equals 22. So we write our equation, do our slide. Now I'm asking myself, what number plus 9 equals 22? So y is on the left side. I do the inverse operation, which is subtracting. Pull my 9 down, subtracting 9 over here, and then draw my line. It kind of is like the bottom of like an addition or subtraction equation. Notice that I line everything up right underneath each other very neatly. I can see that I have 22 minus 9. I can see I have 9 minus 9, and then y is alone. That's on purpose. We want them all lined up super neat. It's okay if you use 4 to 5 to 6 to 7 lines of paper on your notebook. I'd rather have you use more lines on your notebook than try to cram it in into one line where you can barely read and it's all unorganized and out of place. These equations, this unit, you're going to use more paper than you're used to. All right, so 9 minus 9 is 0, so we have y plus 0 equals, and then 22 minus 9 is 13. I'm going to rewrite it as y equals 13. Then I bring my 13 back into my equation, so 13 plus 9 equals 22. 13 plus 9 does equal 22, so I know that y equals 13. Sometimes we can just cross that off, so we know that those just cancel each other out. If you like that idea and you want to do that, that's fine too. All right, negative 5 equals g plus 6. So there's my slide to separate my left and right. Now I can see that the variable is on the right side and it's being added to 6. So I do the opposite, which is subtracting 6, and then I subtract 6 over here. Remember, you have to do the same thing on the left or the right. If you do it over here, you have to do it over here. So I know 6 minus 6 is 0, so I'm just going to cancel that out. I'm going to rewrite this because I have negatives and I have subtraction and it gets confusing. I can do just g, or I can do g plus 0. And then I have negative 5 minus 6 is the same as plus negative. So negative 5 plus negative 6. Now we get to think back to unit 6 for our integer rules. Both negatives, so I add them together. I get negative 11 equals g. I always like to have the variable on the left side. So if we if we start with the variable on the right side, we always want to end up with our variable here. So g equals negative 11, basically just flipping it around. Then I rewrite my equation, negative 5 equals negative 11 plus 6. Does negative 11 plus 6 equal negative 5? Yes, it does. So then g equals negative 11. Notice that I circle my answer after I'm done checking it. That's my way of like going back, making sure that I agree. And with all this work, we want it to stand out that that's our answer. All right, you try these 4 on your own and then come back and check when you're done. I'm going to go through these kind of fast. M plus 4 equals 15, so I'm going to subtract 4 on both sides. My line that goes all the way through. So I have M equals 11, and then I ask myself, does 11 plus 4 actually equal 15? Yes, it does. So M equals 11. 5 plus H equals negative 7. So 5 plus something equals negative 7. I know right away my answer has to be way greater than negative 5, because 5 plus negative 5 is 0, and I'm going into the negatives. So my answer has to be, well, I guess I should say less than negative 5. It's going to be way more left of 0. So I'm going to subtract 5 on both sides because that's the opposite of adding 5. 5 minus 5, so now I have 0 plus h. Negative 7 minus 5. Let's rewrite it. So it's negative 7 plus negative 5. So now I have h equals negative 12. And then 5 plus negative 12. Notice that I just take my answer and I put it right back into the equation where the variable was. Equals negative 7. 5 plus negative 12. So different signs. I subtract. 12 minus 5 is 7. There's more negatives. Negative 7, so that works. H equals negative 12. And then negative 3 equals f plus 4. So subtract 4 on both sides. Negative 3 minus 4 equals f. We'll do plus negative. So negative 3 plus negative 4 is negative 7 equals f. Remember, we just want to make sure our variable is on the left. So f equals negative 7, because we would always read it as the variable equals the number. So I would say f equals negative 7. And then negative 3 equals negative 7 plus 4, which does work. So f equals negative 7. All right, so subtraction equations. So we're going to do the exact same steps, except now, if we're subtracting in our equation, we're going to do the opposite and we're going to add. So x minus 2 equals 1. Write that down and then write your slide. So we're asking ourselves, what number minus 2 equals 1? Because we subtracted 2 over here, we're going to add 2. Because now I can see that if I subtract 2 and then add 2, that's just going to cancel each other out and give me 0. So x equals 3. Put that back in. 3 minus 2 equals 1. Yes, of course it does. So then x equals 3. Y minus 3 equals 4. So what number minus 3 equals 4? These types of equations, we want to look at it and say y equals 1. Because we think in our brain 4 minus 3, because we see the subtraction and we see the 4 and we see the 3, but really we're going the other way. We have a number, we're taking away 3 and we're ending at 4. So the number has to be greater than 4. So if we're subtracting 3, we're adding 3 on both sides. That cancels out, so y equals 7. And then let's put it back in. 7 minus 3 equals 4. So y equals 7. Every single time you need to do the check. Okay, and again, like I said, we kind of get in the habit of just doing the check just to do it. But you actually want to make sure that when you're checking it, that it actually checks and makes work. And actually works is what I should say. Because that's your place right there to realize if you got it right or if you got it wrong. Negative 8 equals G minus 6. So G minus 6, I look at the right side because my variable is on the right side. Add 6, add 6. Again, notice that I'm putting my adding 6 like right underneath there and right underneath there. So negative 8 plus 6 equals G. And then I know negative 8 plus 6, so I'm going like to the right towards 0 on a number line. 6 jumps, so I end up at negative 2 equals G, and then I'm going to flip it around, and now I can put it back in. So negative 8 equals negative 2 minus 6. Negative 2 plus negative 6 does equal negative 8, so G equals negative 2. All right, you go on and do these 3 on your own and come back and check. So M minus 7 equals negative 12. Add 7 to both sides. M equals negative 12 plus 7. So negative 12 and then going towards the right. So I'm going to end up at negative 5. And then I have negative 5 minus 7 equals negative 12. Yes, that works. So M equals negative 5. These negatives are the ones that kind of throw us off because we are subtracting negatives and adding negatives, and that's sometimes where we make our mistakes. So H minus 6, so I look over here, add 6, draw my line all the way across. Negative 5 plus positive 6 is going to get me at 1 equals H, and then I just flip it around. H equals 1. So negative 5 equals 1 minus 6. And I know that 1 plus negative 6 does equal negative 5, so H equals 1. And then negative 18 equals F minus 4. Notice I do my slide without even thinking about it. Write the equation, do the slide, every single one. Look at the side with the variable, which is F minus 4. I see that it's subtraction, so I do the opposite, which is addition. Keep that number the same, so plus 4 plus 4. And then that cancels out. I have F alone. Negative 18 plus 4 is negative 14. Flip it around. F equals negative 14. And then negative 18 equals negative 14 minus 4. Yes, that works. So F equals negative 14. All right, last slide. I'm trying to talk quick, you guys, because I know this video is getting long, but it's so important to know all of this. And this topic is really confusing. So it's okay to be a little bit confused, but either way, I want all of those examples written down. Last thing that I want you to write down is subtraction property of equality and addition property of equality. And all that you need to write, just write those two things. And then for your definition, we can see the subtraction property of equality says that if you subtract the same number from each side of an equation, the two sides remain equal. And if you add the same number to each side of an equation, the two sides remain equal. So you can just write for both, or like together, one definition. If you add or subtract the same number from each side of an equation, they will remain equal, which is what we've been doing for all of our equations we just did in this video. We added or subtracted, depending on what we started with. We did the opposite. We added or subtracted the same side, the same number from each side, and they still were the same. All right, that is all. Have a great night. Make sure your notes are in class tomorrow with all of these things, probably 1 to 2 pages. That's what I'm expecting. I will see you tomorrow.